Hi everybody, welcome back to Math 1351, more on math. Today we're going to talk about Chapter 10, Section 1. Well, first off, Chapter 10 deals with data analysis and statistics, an introduction. Section 1 deals with designing experiments and collecting data. Our objectives in this first section: we're going to discuss designing experiments to collect data, variability in data and how it relates to the study of statistics, the differences between population and sample, that's a very important distinction, misuses of statistics based on samples and populations. The statistical questions themselves are important, sample data analysis methods and interpretation across grade levels, and we'll end up discussing statistical inferences. What can we infer from what we learned? To begin with, the American Statistical Association said that about the statistical education of teachers, called SET. This is what they determined. In 2015, the American Statistical Association released this summary: what students pre-K to 12 should be able to do in the development of statistical reasoning. This is page 13 of their findings. Number 1, they should understand how to ask and investigate statistical questions, collect data and design simple experiments to compare two treatments, distinguish, sort, classify, and organize data, understand that data vary, not all data is the same, understand a distribution of data, and describe its key features. Not feathers, but features. Represent distribution with tables, pictures, graphs, and numerical summaries. Compare two distributions. Recognize when there is an association between two data variables. And understand how to make inferences from data and limitations of the scope of inferences beyond the population where the data were collected. In other words, even though we come up with a solution in our study, it's only of a sample, not the population. So it's very important distinction there. To begin the statistical reasoning development in this course, we deal with categorical and numerical data, representations of data, and key statistical concepts including measures of central tendency and of variations and misuses of statistics. That last part is very, very important. You grow up listening to and hearing all sorts of statistics from everywhere. The media. How many times have you heard commercials about toothpaste? 4 out of 5 dentists prefer Crest. Well, what do we know about what doctors they ask, where they ask, what kind of questions they ask, when they ask them? All that stuff is important to know. All right, let's do the first look at observational studies. All right, in statistics, there are two types of studies you can do. One of them is quantitative. The other one is qualitative. Quantitative, everything that you're studying can be brought down to numbers. There's surveys, test results, counting how many students are absent in a single day. Qualitative analysis is by observations, interviews. So it's not really quantified, not really broken down numbers. It's opinions of what you have of the people you're observing, or the people, and when you're asking, what they're asking, how they're asking. So these are two distinct differences. And of course, in a study, you could combine them too. That's called mixed research. All right, observational studies. Research observes how variables interact with one another with no manipulations. That's an observational study. You observe what people do. You observe how they do it, where they do it, why. Then you don't know why they do it yet, but you're observing. What you end up with after you do that conjectures, educated logical guesses can be made. Again, you don't know exact reasoning why, but you can observe and make ideas, guesses why. Observational studies are less reliable than experimental. Okay, what's experimental? An experimental study. This is one experimental study manipulates one or more of the variables to see if any differences in outcomes occur. In experimental studies, you usually have an experimental group and you have a control group. So in the experimental group, this is the one where a variable changes. And in the control group, nothing changes. It's let it go as it normally goes. All right. Now, with the variables that change, we have independent and we have dependent variables. What's the difference? Well, independent is the cause or treatment, and that's dependent. I'm sorry. Independent is the results. And I'm sorry, I had it right the first time. The independent are the cause treatments, the dependence of the results. Think of mathematics. The x is the independent variable, and y is the dependent variable. In other words, this, the same as in your experimental group. The researcher can change this variable, the input variable. Once the researcher determines, okay, X is going to be 2. So that's independent. It can be whatever it wants to. Once we get that, 2 times 2 is 4, plus 3 is 7, then the value of Y depends on the value of X. Same thing in research. If you're studying student behavior before or after lunch, how you can control it? Let them have longer recess. Does that change the effects of the students? Giving them more TV time in class, does that affect the behavior of the students? So these are all independent versus dependent variables. Okay, so first we talk about observational studies. Because this one is just observing. There's no treatment of any sort. Experimental is where you have a treatment, a control group, and an experimental group, and you just watch, see what happens. And the third type of studies you can do is called a sample survey. A sample survey study, these could be questionnaires, interviews, if every 10 years the United States does a census. Now, the difference between questionnaires and interviews versus census. Census is of the population. The government does that every 10 years by law, just to see how many people are in which area, so it can better determine how much money goes to each area. The more populated areas need more government help, so that's what they need to know. Every 10 years, that's what they do. Questionnaires and interviews are over sample spaces. You can't, if you do a questionnaire, you can't questionnaire the entire United States or entire world. So you do something smaller and try to guesstimate what the population would say. All right, the second thing we're talking about is variability of data. When we talk about variability of data, what we're doing is we're discussing the amount by which the pieces of data in a specific data set differ. That's variability. You have one data set, we call it the sample space, and we see how all the data inside here, how it behaves, and if there's any changes on it. And we try to determine what causes that variability. There are several types of variability. Okay, so the first type. Measurement variability. Measurement variability. The word measurement means a couple of things. One, it could be how humans do things. I call that human error. In other words, if we have a class full of students and give them all the same ruler, ask them to measure something, we may get more than one answer. It all depends on how they measure it. Or it could be an instrument error. Measurement is how the instrument is how people interpret the question being asked them on an interview or a survey. So that's the first type. The second type is called the experimental variability. These are the changes that will happen inside an experiment. What this thing means is different treatments cause different results in an experiment. Remember, in an experiment you have a control group, you have a experiment group. And in the experimental group, you change one of the variables. That's the treatment. The variables are the treatment. The different ways you change the variable can cause different results. For example, if the students in your classroom are tired and you turn up the heat, that's going to make them more upset. Or if you don't give them a chance to relax, that'll make them more upset. Because you give them, the treatment is downtime, relax time. It will cause different results in the students. They'll be less attentive and be more anxious in the classroom. So, different treatments cause different results. That's the experimental study, or variability. And sampling variability. Sampling variability is the sample itself. Sample selected or used may not represent the population. For example, in the political study, if you go to a certain town where everybody is one specific way, then their votes may be skewed towards one of the political candidates. So the sample may not reflect the population's opinion. And it's also very important to note the role of context is important. When considering how much variability is acceptable. What is the context of your survey? What is the context of your study? So, your questionnaire, your survey, what are you observing, when you're observing it. So, each one of those will have a specific level of acceptance and variability. All right. Population versus sample. Population is just that. It's the total group of objects studied or involved. It's every one of them. If you miss one or a couple more, then you have what's called a sample. It's a subset of a population. A population gives you exact measurements. A sample will give you an approximation. If you think about it, it's in each political campaign year, election year, what they do is they have samples. They go around and ask maybe 100 people each town, what do you think, what do you think, who do you think is going to win? That's an approximation. At the end of the election, how many people voted, that's the population. That's the exact measurement that's being discussed. Now, in samples, there are two types. We have what's called a random sample. The random sample is where each member of a population has the same chance of being selected. It's done by random. Just you go to any town, and if you're studying that group of students or individuals in that town, anybody you pick, each member in the population has the same chance of being picked. Or we have a simple random sample. So simple random sample is any subset of the population has the same chance of being the sample. So any subset of the population has the same chance of being the sample as any other same-sized sample. For example, if you go to a university, a campus, each grade levels, freshmen, sophomores, juniors, or seniors, they're all subsets of the population. And they each have the same chance of being chosen to do the study. So that's simple random sample. So you pick a subset, a subgroup of that population. Males versus females. You can go by gender, you can go by race, color, creed, whatever analysis you're making at the time. Okay, number 4. Misuses of population and samples. Or populations and samples. What's the size of your study group? Or is it, if you give a survey out, is it the total number of surveys sent out, or total number of surveys completed? We don't know you have to know what size you're dealing with. statistics of the size or subgroup chosen. What that means is like 4 out of 5 dentists. Okay. Did you only ask 5 dentists? Or is it 80 out of 100? Or is it 800 out of 1,000? Or so, what's the size? Or what subgroup? Dentists in a certain town next to your company. So if you ask all the dentists near where they make Crest toothpaste, they all get that stuff pretty much free, the sample size ones. So of course they're going to say, we always give this. So it's statistics on the size or the subgroup that being used. Comparison with other items. This toothpaste resulted in fewer cavities than its nearest, I must put that in quotes, competitor. By nearest, did you mean here's your toothpaste, here's a rock? That's the nearest competitor, is a rock. Or is it toothpaste versus motor oil? So who did you compare it to? Location of survey. Like earlier, was the survey done next in the same town where the toothpaste is being made, or is it across the nation? Where did the survey take place? Wording on the survey. I mean, you say did this toothpaste taste worse than your worst dinner? So, if all of them say no, this had the most favorable taste. So it's the word, how the wording is done in a survey is also important. And there are other that you could think about. So, you hear this kind of stuff all the time. Be very careful when you listen to news or commercials and propaganda stuff like during election times. What are they saying? Who are they saying? So, here's what you need. Needed information to determine fairness of a study. Whenever you read anything, any type of commercial or advertisements or a claim by a company or a politician or anything, what questions were asked? Can you see the survey? You see what kind of questions, how they're being asked. the number of surveys received, completed, sent out, all this sort of stuff. You want to know what information. If they sent out 1,000 and received 100, but only 10 were completed, that's pretty bad numbers. That's 1%. So that's very important to know as well also. Number 3, number of respondents. How many people completed the survey? How many people answered the survey? How many completed it? Number of respondents chosen. All the respondents, did you use all of them, or did you take a subset of them? Or if you took all the results and decided only to use the male or the female, how many of those were actually chosen now? Number and type of items tested. Like toothpaste. Did you only compare it against one toothpaste or one item, similar item, or is it different? So you have to know how was the test, what items were compared to make that claim. How were the answers interpreted? You want to know, okay, once they got the answers, what do they mean? What are they interpreting from them? Are they distinctively positive yes or no questions, or are they Likert questions, like 1 through 5 scale? So how did the people interpret those results? All right, so be very, very, always ask questions. Don't just take anything for face value. So here's an example. Random sample of cafeteria food at a school. So here we're going to discuss what's called bias or an unbiased. In this first one, okay, you ask the question of students in the playground. Who didn't eat lunch. Students at a single table. Every 4th student entering the cafeteria on a given day and lastly, every 4th student entering the cafeteria on any All right, now we're looking here is biased versus unbiased. Is it, in other words, biased means is it influenced? Unbiased means not influenced. So the students in the playground didn't eat lunch. If you ask them what they think about the food at the cafeteria, what do you think? This is bias. Because they chose to be in the playground because either one, they didn't have money for lunch, or they didn't like the lunch. So that's already a biased group. Students at a single table, is that biased, influenced, or not? Is it influenced or not? This is also bias because of peer pressure. You don't know if the people on the table are going to answer honestly, or are they going to, whoever answers first, everybody's going to agree with them or side with them, whether they like it or not. How about every fourth student entering cafeteria on a specific day? Well, this one is unbiased, with limitations. You could have a school field trip that day, then you have less people to interview. So, but it's unbiased because it's random. The most unbiased is just every fourth student or every nth student on any given day. Just ask them as they come in. And it's not on a specific day, that way you don't have to worry about if it's a field trip or school function, something like that. So that's pretty much what random sampling looks like. Issues in designing statistical studies. Now, these are in your classroom as you being teachers. You have to remember this. Before students start doing statistical studies, students should be knowledgeable about the process of evaluating statistical claims. For example, there's a claim on a candy box. 40% peanuts in this bag. So the students open the bag and count how many peanuts, how many other things are in there, and they found out that this only has 41% or 38%. Then they make the claim out they're lying. No. There's a margin of error. That means it's an acceptable range based on, well, many reasons. So they can't just take face value what that number means right there. Because remember, it's the law of large numbers. That one bag may only have 38%. Another bag may have 41%. Another may have 45%. But after everything's said and done, after a whole bunch of different analysis, then after those bags are analyzed, you'll see the average comes up pretty close to 40% on the dot. So they have to understand the concepts of statistical analysis and what they mean when they evaluate the claims of manufacturers. Let's consider how to formulate statistical questions. Collecting data, analyzing data, how the data is displayed, and how to interpret the results. So as a teacher, you have to make sure you cover all these before the students start doing their own statistical analysis. What questions are you going to use? How are you going to collect data? What are you going to use to analyze data? How will you display the data? And once you get the data and you put all that sort of stuff, and you get numbers, results, how do you interpret them? Whether it's success, failure, inconclusive. So we do this by formulate the research question, from groups, individuals, other subgroups, analyze the data for measures of central tendency, and variance, and others. This one here we'll cover later on in this chapter. What graphing mechanism will be used to display the data? And then what rules are going to use to analyze the data? Alright, so let's look at these. Let's look at the first one. Formulating statistical questions. When you create the questions for analysis, you have to consider does the question have an inherent bias? Is the wording prejudicial, or will it influence somebody? Here's some examples. You're comparing classical versus rap music. You can tell me if it's biased or fair. So first one. Is classical music more soothing versus loud rap music? Yeah, this is definitely biased. Is classical music more soothing than loud? No, the way you worded the question, you're influencing classical music as soothing and quiet and relaxing. So be very careful about that. The age groups listening to rap music. So if you focus on the age groups listening to rap music, will that be biased or fair? Well, it's a fair question, because you usually don't listen to loud rap music when you're 80, 90 years old, or it's loud because you can't hear it. So age groups, yeah, that's a fair question. Does rap music have classical roots? That's fair. It's a yes or no question. Does it have classical? Is it based on something already done? Can rap music be considered classical music? Again, that's not influencing, that's just asking a general question. Rap music artistry and sophistication is it the same as classical music? So you're saying, is rap music, is it artistic or is it sophisticated? Is it the same as classical music? That's very biased, because you're saying this one is artistic and sophisticated, because is it the same as? I could tell you I'd much more rather listen to rap music than opera music. So, yeah. Let's look at another example. So here's another example. In the following, describe any bias. Okay, the first one. Go into a first grade. The question you give the students: do you have a pet? Is it an evaluation, or is it biased? Well, first off, that's not a statistical question. Because all it does is it's a determination. It's a yes or no. Do you have a pet? Yes. No. The fourth grade. If you ask them this question: how many good pets do you have in your house? The word good is biased. How many good pets do you have in your house? Well, they have to all be good because you have them at your house. You wouldn't keep dangerous animals in your house, especially at fourth grade level. Grade 7. Do students have more pets in grades 1 than 7? Do students have more pets in grades 1 through 7 than 7? Is that a fair, unbiased question? Yes. That's fair. Because it's asking a comparison between two groups. You could do it is statistical. You can now compare what people think of those two groups. Collecting data. When you collect data, you have to be conscious about from whom and where you collect the data. You want to make sure it's a well-rounded, broad spectrum of individuals and locations. How will the data be treated once collected? In other words, once you collect the data, what's going to happen with it? Are you going to analyze variability in the data? Are you going to analyze, look for any holes or spread of the data, which is also called the range? So, what are you going to do with it once you get the data? Here are some examples. A nurse draws blood from a patient for analysis. How is that a valid collection of data? Yes, because it is random. Anytime you go over there, the nurse pokes your arm and gets the blood. The time of day, it's whether you ate it or not. This is a snapshot of your behaviors and mannerisms and how you live, so they have a better picture of what your blood says. The U.S. Census. Is it valid collection of data? Yes, as data collection, but not random. Because you're doing the entire population. The analysis of data. Once you get the data, what are you going to do with it? Interpreting data. It must be related to the original questions of the survey or interviews or anything like that. So when you interpret the data, make sure that you only analyze the questions that are relevant to what your questions are asking. These are more difficult interpretation to interpretation or in interpretation of data. More difficult interpretation of data that deal with inferences. Because what this means is, what I'm trying to say here is, what can you infer? From the data presented. So that's pretty important. What do you do with it once you get it? Well, from there we have what's called statistical inference. Once we have the data, we analyze it, we have statistical inference. We draw a conclusion based on the data and its relation to our hypothesis. What that means, our hypothesis is just an educated guess. A perfect example here is political polling. Political polling just goes to certain places, and what they do is after they collect all the data, say, okay, this person's going to win because of our surveys. They say that more people are going to vote for this person. All right. Good luck, everybody.